Hello, good evening all and welcome to our channel Chemflix. And if you are new to this channel, please subscribe the channel and also click on the bell icon for getting the notification for uploading new videos. And also like and comment, also share among your friends. Okay, and today we're going to discuss about the part 2 of acids and bases. So how do metals, carbonates and metal hydrogen carbonates react with acid? What do you mean by this metal hydrogen carbonates? It is metal bicarbonates. So one of the example of metal carbonate is sodium carbonate, and another one example of it's magnesium carbonate and whatever be. And about metal hydrogen carbonate, it is sodium bicarbonate, magnesium bicarbonate and so on. What happens when these type of carbonates and bicarbonates react with acids? Today we're going to see that. So this is the activity which is in your textbook, okay, activity 2.5. It says that take two test tubes and label it as A and B. Okay, so you have two test tubes, two boiling tube, okay, and take about 0.5 gram of sodium carbonate, that is nothing but Na2CO3. You can see the chemical formula of sodium carbonate here in the test tube A, and about 0.5 gram of sodium hydrogen carbonate in test tube B, that is sodium hydrogen carbonate or sodium bicarbonate is NaHCO3. So you can see here the two reactant that you are taken here is sodium carbonate and sodium bicarbonate, and now you're going to add 2 ml of dilute hydrochloric acid to both of this test tube. Okay, you're adding 2 ml of dilute hydrochloric acid to these two test tubes, one test tube A containing sodium carbonate and two test tube B containing sodium bicarbonate. And you need to record what do you observe. Okay, you need to record what you observe in your class workbook or whatever be, and pass the gas produced in each case through lime water. What is actually lime water? Lime water is calcium hydroxide solution. Okay, you need to pass the gas which is produced by the reaction of the sodium carbonate with this dilute hydrochloric acid, or sodium hydrogen carbonate with the dilute hydrochloric acid, through lime water which is taken in another one test tube. You can see the diagrammatic representation or the pictorial representation here. This is your experimental setup. And record your observation. You need to record the observation. So that is activity 2.5. Okay, I will show you the video regarding this. Okay, so this is a particular video that I collected from YouTube itself. So here it is your demonstration table. You can see here two test tubes, and here you are going to see how do metal carbonates and metal hydrogen carbonates react with acid. Okay. The aim is to show how the metal carbonates and hydrogen carbonates react with acid. And the materials required are stant, you can see cork, test tube, and delivery tube. Here is delivery tube, this is, and dilute hydrochloric acid, 2 ml of dilute hydrochloric acid is here. And take these two test tubes A and B and add some amount of sodium carbonate in test tube A. Here it is sodium carbonate and here it is sodium hydrogen carbonate. You are taking test tube A and B. And now you are going to pour this hydrochloric acid to it. Okay, add small amount of dilute hydrochloric acid. And after adding dilute hydrochloric acid, we can see the evolution of gas with bubbling on both of the test tube. Okay, and pass these two gases separately through this delivery tube into this calcium hydroxide, that is lime water containing test tube. Okay, so that is the experiment, and you can see a white precipitate formed here. Both of this test tube containing a white precipitate, and this white dense precipitate is due to the formation of calcium carbonate and water. Thus we can conclude that the gas evolved in these test tubes are carbon dioxide. So let's see this chemical reaction. What are the chemical reaction here? When hydrochloric acid react with sodium carbonate, okay, when hydrochloric acid react with sodium carbonate, the resultants are, or the products formed are, this is a salt which is sodium chloride. You can see this is NaCl. HCl, when it react with Na2CO3, you will get NaCl plus CO2 and H2O, and in test tube B, you will get it as sodium chloride, carbon dioxide and water, same. So on passing excess carbon dioxide into lime water, that is the second step. Okay, passing excess carbon dioxide into lime water, it forms calcium bicarbonate, which is soluble. So when acid react with metal carbonate or metal hydrogen carbonate, salt of the metal, carbon dioxide and water are formed. So the formations are sodium chloride, salt, water and carbon dioxide. And test tube B, when sodium bicarbonate react with hydrochloric acid, you will get NaCl, that is the salt, water and carbon dioxide. Okay. Gas through lime water, it turns milky because insoluble precipitate calcium carbonate is formed as shown in the below. That is calcium hydroxide. When it react with carbon dioxide, it will form calcium carbonate, that is the white precipitate, plus water. And on passing carbon dioxide gas through lime water, it becomes colorless. On passing excess carbon dioxide, while you are passing excess carbon dioxide gas through lime water, it becomes colorless. That is calcium carbonate plus H2O plus carbon dioxide, excess carbon dioxide, you will get calcium bicarbonate, CaHCO3 twice, that is calcium bicarbonate, which is soluble in water. Okay, so that is our experiment. In short, these are the chemical reaction or the chemical properties of acid. When acid react with a metal, it will give hydrogen gas. When acid react with metal, it will give hydrogen gas along with salt. And when acid react with metal carbonates, it will give carbon dioxide and water along with salt. And when acid react with the metal hydrogen carbonate or metal bicarbonate, it also gives this, it's same, that is carbon dioxide, water along with the salt. And this is one particular property of this acid. When acid react with the metallic oxide like calcium oxide, sodium oxide, magnesium oxide or whatever be, when acid react with this metallic oxide, you will get salt and water. Okay, so these are the chemical properties of acid. Now we're going to see the chemical properties of base. So these are the chemical properties of base. When it react with the metal, it will give hydrogen gases same as acid along with salt. And with non-metallic oxide is carbon dioxide. And when it react to this base, that is calcium hydroxide, you will get calcium carbonate, which is a salt along with water. Okay, so these are the chemical properties of base.
Next we are going to discuss about neutralization reaction. What do you mean by neutralization reaction? Neutralization reaction is nothing but an acid and a base reacted to form water. Okay, quantitative amount of acids react with a quantitative amount of base to form water along with salt. This is what is called this neutralization reaction. For example, acid is HCl. I am taking acid as HCl and base as sodium hydroxide. And here this OH minus ion, that means the hydroxide ion, get combines with the hydrogen ion of the acid and it forms water along with salt. The salt is actually obtained when hydrogen of acid is replaced by metal. Okay, here hydrogen is replaced by metal, then you will get sodium chloride. Similarly, if you any type of acid you are taking, for example, if you are taking H2SO4, for example HNO3, whatever be the acid, you will get the salt and water. That is neutralization reaction. So here an activity 2.6 is depicted in your textbook, that is take about 2 ml of dilute sodium hydroxide solution in a test tube and add 2 drops of phenolphthalein solution. You know, dilute sodium hydroxide is a base. So in sodium hydroxide, which means in base, the color of the phenolphthalein solution is, you can see here, it is pink. Okay, so add dilute hydrochloric solution to the above solution drop by drop. So what happens? The H plus ion, gradually the concentration of H plus ion increases. That means the color just faints and reaches this 7. You know, neutralization means acid and base react to form a salt with water. Okay, salt and water. Water is, what is the pH of water? Water is, it's not pH, water of, okay, pH of water is 7, or water is a neutral substance. Okay. Why did the color of the phenolphthalein change after the addition of an acid? Why is it so? Because while you are adding acid, the concentration of H plus ion increases. That's why you can see the color of the phenolphthalein just disappearing. Does the pink color of phenolphthalein reappear? Of course, when you add a few drops of NaOH to the above mixture, the pink color of the phenolphthalein reappear, because while you are adding a sodium hydroxide solution, the concentration of OH minus ion increases, which means the basic property increases. That's because of that, the pink color of the phenolphthalein reappear. Okay, so let's see actually what happened. This is activity 2.6. You can see a diagrammatic representation. NaOH base, when I am adding this phenolphthalein, it appears as pink color. You know, the base color of the phenolphthalein in basic solution is pink. And I am going to add HCl drop by drop. You will get a neutral solution which is colorless. Again I am adding sodium hydroxide base. Due to the increasing concentration of the hydroxide ion, it changes its color to pink. So the reaction between acids and bases is, acids and bases nullify each other's effect. Acids are equal amount of acid and bases. That means quantitative amount of acids and bases, when react each other, it nullify each other's effect. Acids and bases react with each other to form salt and water. This is nothing but a neutralization reaction, and this is, you can see the reaction between an acid and a base to form salt and water. Next we are going to see what happens when metallic oxide react with acid. Okay, activity 2.7 says that take a small amount of copper oxide in a beaker. Okay, copper oxide, that is CuO, you know, and add dilute hydrochloric acid slowly while stirring. Okay, you have to add dilute hydrochloric acid slowly and stir it. Note the color of the solution and what has happened to the copper oxide. Okay, let's go and check. Okay, here you can see I'm taking some copper oxide and take it into the boiling tube. Okay, that is copper oxide. You can see the color of the copper oxide there. Now I'm taking this acid using a dropper, and I'm going to add this acid to the copper oxide drop by drop slowly, and I shake the boiling tube very well, and you will see the copper, which was in insoluble form in copper oxide, has reacted with the hydrochloric acid and formed a soluble salt with the chloride ion from the acid and formed copper chloride. So it is actually copper chloride. The solution now contains copper chloride. So the green colored solution is copper chloride. So when metal oxides react with an acid, metal oxides form a salt with the negative ion of the acid. That is CuO. When we react with the 2 HCl, you will get CuCl2, that is the negative ion, plus H. So here to the copper oxide, which is taken in a beaker, we are adding dilute hydrochloric acid and stirring it. You will get blue-green color forms. It is due to the formation of copper chloride. That is CuO. When it reacts with hydrochloric acid, you will get copper chloride. This is the salt plus water. And metal oxides react with the acid to form salt and water. Okay, that is the inference. Metal oxides react with acid to form salt and water. Metal oxides here act as base here. What is this metal oxide? Acid. When react with the base, you will get salt and water. This is according to neutralization reaction. So here it is acid. Already acid is there, and our products are salt and water. So the metal oxide here act as base. Okay. So what is the behavior of metal oxide here? Metal oxide act as base. So we can conclude here as metallic oxides are basic oxides and non-metallic oxides are acidic oxides. So metallic oxides react with acid to give salt and water, similar to the reaction of base with an acid. And non-metallic oxides react to the bases to give salt and water, similar to the reaction of an acid with a base. Okay. Okay guys, so hope you all understand very well, and if you have any doubts, kindly please put in this comment section, and if you like this video, please give a thumbs up and also subscribe to my channel. Okay, thank you all. Thank you once again.